Hello, in this video we will be discussing how to draw the graph of a quadratic equation. Drawing the graph of a quadratic equation can be simplified into 6 different steps. We will explain these 6 steps with the use of an example. So the example says, sketch the graph of y equals f of x equals x squared minus 6x plus 5. Solution, step 1, we have to find the x-intercept coordinates. X-intercept means what is the value of x when y equals 0. So x-intercept means what is the value of x when y equals 0. So that means we'll go to our equation, which is y equals f of x equals x squared minus 6x plus 5. So we are looking for the value of x when y equals 0. That simply means we replace y with 0. So 0 equals x squared minus 6x plus 5. You don't have to worry about this f of x here. It simply means the same thing as y technically. So we've replaced y with 0 because we are looking for the value of x when y equals 0. To solve this, we can rewrite this in a way that is more familiar, which is x squared minus 6x plus 5 equals 0. We can remember this from the general quadratic equation, which is ax squared plus bx plus c. So we can say that this equation is a quadratic equation. So to find the x, we can either use factorization method or we can use a quadratic formula. So let's use quadratic formula. To use a quadratic formula, the first thing we need to do is we have to determine the value of our a, we have to determine the value of b, and we have to determine the value of c. So from this equation, a is the coefficient of x squared. Coefficient of x squared in this situation here is 1. So a equals 1. B is the coefficient of x, the number beside x. The number beside x is minus 6. It's important not to ignore the minus. So b equals minus 6. And c is the number without no x, and that's plus 5, or we can simply call it as 5. c equals 5. Now that we have determined the value of a, b, c, next thing we need to do is calculate delta, the discriminant. The discriminant delta equals b squared minus 4ac. Solving for delta, delta equals b squared is minus 6 all square minus 4 into 1, a is 1 and c is 5. Hence, delta equals minus 6 all square is 36, minus 4 times 1, that's minus 4, and then minus 4 times 5, that's minus 20. So delta equals 36 minus 20 will give us 16. So that means our discriminant is 16. So since delta is greater than 0, that is delta is positive, this means we will have two real roots. So we will have an x1 and x2. We will have two x's. So x1, the first x, equals minus b plus the square root of delta divided by 2a, and x2 equals minus b minus the square root of delta divided by 2a. So the first value of x equals minus b, that's minus 6, because the b in of itself is a negative number. So minus 6 plus square root of delta is 16 divided by 2 multiplied by a is 1. So simplifying, we have the first x equals minus times minus. So we have minus times minus 6. That will give us plus 6 plus square root of 16 is 4 divided by 2 So going further, that's x1 equals 6 plus 4 is 10. 10 divided by 2. So 10 divided by 2 is 5. And for the second x, x2 equals negative b, which is minus 6, minus square root of delta, which is 16, divided by 2 multiplied by 1. Simplifying, we have the second x equals positive 6 minus square root of 16 is 4, divided by 2. Simplifying, 6 minus 4 is 2, divided by 2. So the second value of x equals 1. So this is step 1. Step 1 involves finding the x-intercept coordinate. Now that we found the value of x when y is 0, we need to determine the coordinates of this step 1. So since we have two x's, this means we will have two respective coordinates. Remember that a coordinate system is always x, y. The value of x comes first and then the value of y. So in this situation here, the coordinate here is the value of x is 5, the value of y. Remember that we said what is the value of x when y is 0. So this means the coordinate is x is 5, that means y is 0, because the value of y is 0. When the value of y is 0, we will have 5 as the first x. So that's the first coordinate. And the second coordinate, the value of x here is 1, and the respective value of y here is also 0, because we got this 1 as a result of making y equals 0. Hence, this completes step 1. So step 1 involves finding the x-intercept coordinates. Now moving on to step 2, which is find the y-intercept coordinates. Y-intercept coordinate. So y-intercept means what is the value of y when x equals 0. So we are looking for the value of y when x equals 0. So we go back to our function, which is y equals f of x equals x squared minus 6x plus 5. So we are looking for the value of y, so we leave y as y when x equals 0. That means our f of x is f of 0, and that's equal to, anywhere we see x in the equation, we'll replace it with 0. So we have 0 squared minus 6 into 0 plus 5. So that means we simply have y equals 0 squared minus 6 times 0 plus 5. So simplifying, we have y equals 0 squared is 0 minus 6 times 0 will give us 0. So negative 0 or positive 0, it doesn't matter. Then plus 5. So when we simplify, 0 minus 0 is 0, and 0 plus 5 is 5. So which means when x equals 0, the value of y is 5. Hence, the y-intercept coordinate is, the value of x is 0, the value of y is 5. Why is the value of x 0? Because we said the value of y when x is 0. Hence why we have x is 0, 5. And this completes the second step. The third step is find the vertex coordinates, find the vertex point coordinates. To find the vertex point coordinate, the vertex point coordinate has a formula. The formula can be written in two different forms, but they actually mean one and the same thing. The first possible form that the formula can be written is the vertex point is, of course, like every coordinate, it works with an x comma y system. So that means we have x comma y is equal to, for the x, that means we have minus b over 2a, comma, for the y, it is minus delta over 4a. This is the first way the vertex point can be calculated. The second way, which is also a x comma y system, equals, the x still remains the same as minus b over 2a, comma, instead of calculating y on its own, we simply take the value of x and we substitute it into the function. So we have f of minus b over 2a. So this means if we get the value of x after calculating minus b over 2a, we simply take the value that we get from the x, we substitute it back into the equation. That will give us the value of y. So for example, if x gives us 4, that means x equals to 4. So we take this 4, put it inside the function. Whatever we get as a result will be the value of y. That is what this means. We will use both ways and then we can check that the answers will be exactly the same. So using the first way, our x equals minus b over 2a. So which means x equals the value of b, as we've specified previously, the value of b is minus 6 and the value of a is 1. So we have x equals minus 6 divided by 2a, 2 times 1. So that means x equals minus times minus 6, that's 6 divided by 2. So that means our x equals 3. And y equals minus delta over 4a. So y equals, recall that while we were looking for the x-intercept coordinate, we already calculated our delta and we got delta, which is the discriminant. We got delta, the discriminant, as 16. So this means y equals minus 16 divided by 4 multiplied by 1. So simplifying, we have y equals minus 16 over 4. Hence, y equals negative 16 divided by 4 is 4. So the value of x is 3, the value of y is minus 4. This means the vertex coordinate point is 3, minus 4. If we are to use the second way, x is still minus b over 2a. So if we use the second way and we calculate x equals minus b over 2a, we will get 3. That's the same thing as the first way. But the difference is that when we come to y, instead of using minus delta over 4a, we will have to do f of minus b over 2a. That means y equals f of minus b over 2a, as we've calculated here, minus b over 2a will give us 3. So that means we have f of 3. So this simply means we take this f of 3. It means anywhere we see x in the equation, we substitute it with 3. Remember that our equation is x squared minus 6x plus 5. So anywhere we see x in the equation, we replace it with 3. So we have 3 squared minus 6 multiplied by 3 plus 5. So that means y equals 3 squared is 9 minus 6 times 3 is 18 plus 5. Simplifying, y equals 9 minus 18 would give us minus 9 plus 5. Simplifying, minus 9 plus 5 is minus 4. You can see that the answer is exactly the same thing as this. So which means our coordinate is still 3, minus 4. The value of x is 3 and the value of y is minus 4. That's the vertex point coordinates. The question is, which one should we use? The first way, which we need to calculate the value of y, or the second way where we just substitute the value of x into the equation? Depending on what you have done here, because in this equation here, we calculated the value of the x's using the discriminant delta. If you are used to calculating your x without the use of a discriminant delta, so what I mean is that if you are used to calculating your x as equal to minus b plus or minus square root of b square minus 4ac divided by 2a. If you are used to calculating your quadratic equation like this, then that means you don't have a delta. And if you don't have a delta, you'll have to calculate your delta in order to use this formula, which is probably going to be a waste of time. So it's better to use this second method where you just substitute in the value of x directly into the equation. So we have completed step 3. The next step, which is step 4, it says show all the coordinates on a plane. That is, show the coordinates on a graph. So we have how many coordinates? Let's count. We have 1. This is the first coordinate. Second coordinate. Third coordinate. And fourth coordinate. So that means we have 4 points that we need to show on the graph. Take your ruler and draw your y-axis, and also draw your x-axis, and label appropriately. This is y and this is x, and at the middle here is the origin, 0, 0. What was our first coordinate point? Our first point is 5, 0. So our first coordinate is 5, 0. So we need to show 5, 0 on this graph. So let's say 1, 2, 3, 4, 5. So 5, 0 means the x is 5 and the y is 0. X is 5 and y is 0. That means we are talking about this point here. The second point, which is 1, 0, 1, 0, 1, 0. The value of x is 1 and the value of y is 0. So 1, 0 is this point here. If you are confused on how we got this coordinate point, remember that we said this first and second coordinate points are from the calculation of the step 1, which is the x-intercept. X-intercept simply means at what point does our graph or does the line cut the x-axis. X-intercept means at what point does the graph cut the x-axis. That is, we expect the graph or the curve to cut the x-axis at this point. That is the meaning of x-intercept. So which means the point needs to be sitting on the line. Hope that helps. So we've drawn our first 2 points. The third point, which was gotten from the y-intercept, the third point, which we got from the y-intercept is 0, 5. 0, 5. That means the value of x is 0 and the value of y is 5. So let's scale 1, 2, 3, 4, 5. This is 0, y is 5, which is this point. Or you can look at it as y-intercept means at what point does the curve or does the line cut the y-axis. Cut the y-axis. That's the point here, which is 5. Last point, which is the vertex point. So the vertex point is 3, minus 4. So it means the value of x is 3 and the value of y is minus 4. So I need to scale the y in the negative area. So minus 1, minus 2, minus 3, minus 4. So 3, minus 4 means x is 3, y is minus 4. So when I drop this point and I drop minus 4, these two numbers will meet at this point. Hence, this point here is 3, minus 4. So we've drawn all 4 points. Hence, we've completed step 4. Step 5 says determine the concavity. Determining concavity simply means there are two possible concavity we can have. So we can have the first one, we can have concave up, which means the quadratic graph will look like a U. And the second concavity we can have is what is called concave down, which means the graph will look like an N. So when do we have a concave up? When do we have a concave down? We have a concave up if the value of A is greater than 0. So if A is greater than 0, which means if A is positive. What do we mean by A? Remember that we showed our A here. A is here. A is 1. And how did we get A is 1? We go to our equation and we look. A is the coefficient of x squared. So what is the number beside x squared? The number beside x squared is 1. So since A is 1, that is positive 1, that means A is greater than 0. That means we will have a concave up situation. So if a positive will give us a concave up situation, that means if A is less than 0, if A is a negative number, that means we will have a concave down situation. Determine our concavity. We can see that A is greater than 0, which means draw our graph, we expect to have a concave up situation. So we've determined how our graph is expected to look. Our graph is expected to look like a U. That completes step 5. And lastly, step 6 says join all the coordinates. That is all the points that we've drawn on the graph. We need to join them together with a curve. So we go down to our graph. We join all the points together. We expect that our graph should look like this, a U. So which means I need to start from the top, which is the first one here. Join it with this one. Join it with the vertex point. And then I go from the vertex all the way to this point here. And roughly, this is the graph. So this is the graph of y equals f of x equals x squared minus 6x plus 5. Hence, we've sketched the graph of this quadratic equation successfully. One more thing that is also important to know how to determine is what we call domain and range. Domain always has to do with the possible values of x, and range has to do with the possible values of y. So domain has to do with possible value of x. So we go to this equation here. the possible values of x, which means we need to check from minus infinity here all the way to positive infinity here on this number line of the x-axis. We need to check what are the possible values of x that we can have. We can have infinite amount of x values. That is, x is an element of all real numbers in this situation. Why is that? Think about elongating this line and elongate this line all the way to infinity. There is always a x value corresponding on this line if you look at it from the x-axis perspective. So from whatever point, pick any point on your graph, there is a corresponding x value. That is what this means. So that is why x is an element of all real numbers. That is, x can take on the values of numbers between minus infinity all the way to infinity. Any number within this range can satisfy this quadratic equation. That's one way to look at it. Another way to look at it is we can see that this equation is a quadratic equation. And a quadratic equation is a type of a polynomial equation. So the rule of thumb is if an equation is polynomial, the domain is always all real numbers. As for the range is all possible values of the y. The range is all possible values of the y. So as for range, we have two possible situations. The first possible situation for a range is from the vertex all the way to positive infinity. And the second possible situation is we have from negative infinity all the way to the vertex. So which means the value of y at the vertex all the way to infinity, or we have minus infinity all the way to the value of y at the vertex. This first situation always occurs whenever the curve is concave up. And this second situation usually occurs whenever the curve is concave down. Let's go to the graph here. If we elongate this diagram, we can see that there is always a corresponding value of y. So if I pick this point, the corresponding value of y will be somewhere around here. The corresponding value of y at this point is here. Corresponding value of y is here. Corresponding value of y at this point is here. Corresponding value of y is here. Corresponding value of y is here. So we can say we have a corresponding value of y. If we pick this point, the corresponding value of y is here. Pick this point, corresponding value of y is here. Pick this point, corresponding value of y is here. But the moment we get to this point, corresponding value of y is here. But anything below this point is not on this curve, which means we don't have a corresponding value of y that satisfies this particular curve. So the moment we reach the vertex point is the limit of the y values in this specific equation. So that means the range is from the value of y at the vertex, which is -4, all the way to positive infinity. That is from this -4 all the way to infinity are the possible values of y that satisfy this particular equation. If the graph was concave down, then we will write it in this format. From -infinity all the way to the value of y at the vertex point. And this is how we draw the graph of a quadratic equation. Thank you very much for watching. If you enjoyed this video, please leave it a like and share it. And don't forget to subscribe to the channel. Thank you very much. See you in another video.